Part 4, Intermediate Value Theorem. The intermediate value theorem says this: suppose f is a continuous function on an interval that contains x equals a and x equals b, where a is less than b. If f of a and f of b have different signs, then f has at least one zero between a and b. So there's at least one real number c where a is less than c is less than b, that we have f of c equals 0. So what does that mean? Let's illustrate here. We have on the left side, we have a point a, f of a. So whatever a is, we have it less than b, so it's further to the left on the x-axis than b. Here we have a point b, f of b. Notice the sign of f of a is positive and the sign of f of b is negative. Now whatever the graph's doing, it says it's continuous, so we'll just draw a continuous graph. Doesn't matter what it's doing, but we can see there is a 0, a root, an x-intercept in between a and b. So this would be our number c. So that's what the intermediate value theorem tells us, is if we have a continuous function, at one point if we're positive, at another point we're negative, then somewhere in between we have to cross the x-axis. Now this is helpful for polynomials because polynomial functions are always continuous. So we've met that condition, they're always continuous. So this can help us with polynomials figure out where a 0 is or approximate a 0 if we're not exactly sure where it is. Let's use the intermediate value theorem to show that f of x equals x cubed minus 2x squared minus 5x plus 5 has a real 0 in the interval 0 to 2. To do that, we're going to say, okay, that must mean that if there is a real 0 in between, which is telling us there is, we just need to show that, then f of 0 will be either positive or negative, but f of 2 will have to be the other, either positive or negative. F of x is a polynomial, so it's continuous on its whole domain. The domain is all real numbers, so it's continuous everywhere. F of 0 would be 0 cubed minus 2 times 0 squared minus 5 times 0 plus 5, which gives us 5. So f of 0 is positive. Let's find f of 2. That would be 2 cubed minus 2 times 2 squared minus 5 times 2 plus 5, which is 8 minus 10 plus 5, or negative 5. So f of 2 is negative. So f of 0 is positive, f of 2 is negative. So somewhere in between x equals 0 and x equals 2, we're going to cross the x-axis. We have a 0 or an x-intercept somewhere on that interval 0 to 2. So we can use this to help us graph polynomials because the intermediate value theorem tells us that in between two different x-intercepts or two different zeros, the whole graph is either positive or negative. To do that, to graph polynomials using this, we first need to think about multiplicities of zeros. So let's find the zeros and their multiplicities for the function. So a multiplicity will tell us how many times that 0 occurs. It's really easy to find the multiplicity if we factor the polynomial. So here we have a factored polynomial, f of x equals x squared times x plus 1 times x minus 2 cubed. So the zeros are 0, x squared equals 0 when x is 0, x plus 1 equals 0 when x is negative 1, and x minus 2 equals 0 when x is 2. The multiplicities are just the power on each of those factors. So 0 has a multiplicity 2 because that's x squared. Negative 1 has a multiplicity 1 because it says x plus 1 to the first power. And 2 has a multiplicity 3 because we have x minus 2 to the third power. Knowing these multiplicities will help us graph the polynomial.